everybody. Good morning. The past couple of days we've been working on probability distributions, discrete and continuous. So my objectives for you guys this morning is to take what we already know about probability distributions and apply it to this new concept, binomial probability distributions. And we're going to do that by understanding the definition of a binomial distribution, looking at just kind of the parts of a binomial distribution given like a word problem. So identifying like certain problems that need a binomial distribution to be solved. And then also the formula that will help us define the probability of a binomial distribution. So what, this for some background content and understanding, what is the definition of a just normal probability distribution? This should already be in the notes. Been talking about it for the past couple days. It was given on Monday. Any ideas? What do we know to be parts of or the definition of a probability distribution? Go ahead. Yeah, sure. Yes.
It's a graph that gives the probability for each random value.
All right, thank you. It's a graph. It can also be a chart or a formula too, right? Okay, so that's some of the parts of it. Good, thank you. That was a definition for you right there. What is a probability? What are some components of a probability distribution? In between zero, all the probabilities add up to 1? Yep, exactly. What is 1 as a percent? 100%. So all the probabilities of our probability distribution add up to 100%. Okay, good. And what are each probability also has to have a fit a specific criterion too. What was that? It's in between 0 and 1. We don't have any negative probabilities, but there isn't any probability individually that's greater than 100% either. Does that make sense? Remember all that? All right, so given all that info, let's look at a binomial probability distribution. So, moving forward here. Okay, so it's created from the results of a binomial experiment, which includes that each trial that we're going to be looking at must be independent. Independent meaning they don't rely on each other, the probabilities. So one probability doesn't affect the outcome of the next trial, if that makes sense. The second criteria here is the probabilities remain constant. So if we're flipping a coin, okay, if we flip heads the first time, and when we go to flip it a second time, the fact that we flipped heads the first time has no say on the probability that we get the second time we flip the coin. Third criteria, there are only 2 possible outcomes. This is the really unique part of a binomial distribution. It allows us to sort outcomes and probabilities into true things or false things, successes or failures, all right? So we can sort it out into 2 big categories. So like flipping a coin, you get heads or tails. Or if you're going to do a survey of how many people are left-handed or right-handed, you have an outcome of left-handed people, that would be me, or right-handed people. So just some examples of that. So all the outcomes can be sorted into 2 distinct groups. That's like the heads flipping a coin. That's an example of that. So, but your probability might be different. This kind of depends. We'll look at a sports example. Your probability might vary depending on what team you're playing, but it'll still be unique. And you can sort that into wins and losses, for example, there. The fourth and another important part is that there's a fixed number of trials. All right, so we're not looking at continuous probability distributions here. We can count these. There's a fixed number of them. Does that make sense? So, given all that, let's move on. Any questions on that part at all? Understand the idea of independence and everything? The fourth one, it has a fixed number of trials. So if you're going to flip the coin 10 times, all right, for example, or you're going to talk to 10 people and see if they're left or right-handed. All right, so let's look at some of just the the verbiage here, some of the terms. So P of S is your probability of a success. All right, and we call that P, lowercase p. So that's one of the first things we need to understand. And then the probability of failure is going to be 1 minus P. So we derive failures from successes. And why does that 1 minus P work again? Why does that cover all of the failures? 1 stands for what again? 100%, so the whole thing. Good, good. So we can get the failures from once we know how many successes we have. All right, so N is going to denote the number of fixed trials that we have. So, like I was saying, a binomial distribution has a fixed number of trials, and we call that N when we're going through and doing these problems. X is going to be our successes, okay, the number of successes that we have, and P is the probability, like we just said, and Q is the probability of failure. So let's look at an example here. So we want to determine whether this particular situation, this word problem here, is a binomial distribution or not. All right, so can I get somebody to read this out loud for us? Read the question. We can use a mic, we don't have to though.
AT&T plans that when customers call their assistance, the telephone numbers and the right number is given 90% of the time. Assume 90% rate of correct and assume that 1 to 5 the probability that on 5 requests, 5 of the responses is correct.
Perfect, thank you. So, what do we have here? Do we need a binomial distribution to solve this? What are the components of a binomial distribution that are included? Anybody see any? So what would be N, for example?
Oh, wait, I got 5.
N is 5, right? So that's the number, that's our total number of trials, right? So we have 5 requests. All right, so what would be our X? 3. Okay, we want to see if 3 of the responses are correct. So that's our X here. Good. Let's see if we can roll this down a little bit more. All right, so we have a fixed number of trials. We have a number of successes. All right. What else are we looking for here? So we go back a few slides. We have right there. So we have a fixed number of trials. Are these trials independent? All right. Are the probabilities constant for each one? All right. So the number is given 90% of the time. All right. Assume that they're correct 90% of the time. Is that a fixed, or is that a constant rate of success? All right. Good. So yeah, with the check stat box. And fourthly, we have. No, it's fine. Are there more or less than 2 possible outcomes? How many outcomes do we have? 2. All right. It's correct or it's wrong. Right. So this is a binomial distribution. So we found out what N is. We found out what X is. What would be the probability of success? That would be lowercase p. What's that? 0.9. Right? Exactly, because 90%. Good. And then what would be Q? What's Q? Yeah, what does Q denote?
Failure?
Yeah, probability of failure. So it's 1 minus p, right? So what would that be? 0.1. Good. Good. There we have it. All right, does that make sense to you guys? Yeah. Looking at this example word problem. All right, another one. So here's a sports one. We're talking about the T-Wolves here. They win about 30% of their games. Ouch. Yeah, I agree. You want to find the probability they win 5 games in a month that has 10 games. That doesn't seem like a whole lot of information. Is this a binomial distribution?
Win or lose.
So I heard somebody say they can either win or lose. So we have 2 groups that we can sort our content into, right? So check stat box, yes?
When it goes to the objectives, it has to be all of them?
It needs to be all 4, yeah. It fits all 4 criteria. So do they have a fixed number of games? 10. All right, good. So we have that one. That works as well. Are the trials independent?
Yeah.
Right, yeah, exactly. I mean, it doesn't matter if they win one game and lose the next game. They have the same opportunity to win both, right? I mean, it probably depends whether you're playing who the opponent is, right? Certain teams are better than others, but for our purposes here, it's about an equal chance. All right, so this is the probability distribution. It checks all four boxes again. So why don't we look up what would be n in this case? All right, n is 10. Put it down for right here. Good. How about x? 5. So yeah, we want to see if they win 5 games. All right, so that would be 5 successes. All right, as we're defining it here. X equals 5. What's the probability of x? Right, they win 30% of the time. Okay, so that's what we're operating under here. That's the underlying assumption, and that makes q 0.7 because it's 1 minus 0.3. Good. We are understanding this well. Good. Any questions on that? I don't want to go too fast. Everybody understand where we're getting q from? See it in here? I mean, they only give us, really, in this problem here, they only outright give us n, x, and p. So we had to find q. Okay, so we're a big people, we can handle that. We got it. All right, so those are a couple example problems of how to, recognizing a binomial distribution problem when you see one. So there's a formula, because we can actually find probability with these. All right, and this is a complicated looking formula. Because anyone tell me what this exclamation mark means? Factorial, what does that mean? Exactly. You multiply in succession all numbers all the way down to 1. All right, so if you start at 5, it's 5 times 4 times 3, just like you said. Perfect. Does that make sense? So we have the probability of x is n factorial. What is n again? The fixed number of trials. Perfect. In the last example, it was 10, right? Because we had 10 ball games. So it'd be, and then we have, so it'd be 10 factorial if we were going to apply the last example over n minus x, which would be 10 minus what? What's x stand for again? How many times you're successful, right? Whatever successful is. All right, so x is your number of successful outcomes. So in the last one, it was 5, if I'm correct, right? Wrong way. All right, we had 10 is n, and x is 5. So in this case, it'd be 10. We'd have 10 factorial over 10 minus 5 factorial, right? And then x factorial again, which is just what? 5 factorial, just like we have over here. Okay, good. Actually, this should be outside of that. And then what's q? Oh, I skipped b. Sorry, what's b? It was 0.3. Yeah, it was 30% chance of winning the ball game. So that p is or percentage of a chance that we're going to be successful. So then you'll have 0.3 to what? It's at 5, right? Because that's the number of successes that we're after. And then we have q, which is what again? 0.7. It's our probability of failure. And then we take that to n minus x, so 10 minus 5. And that would be how we find, so that's our primary formula for finding probability with a binomial distribution. This is useful. The second one is useful for your calculator. All right, the C term here. We'll talk about that in a few minutes. So on just how to plug that into our calculators. So let's do a quick problem. I think we have some worksheets here that we can start looking at now. Thanks, guys. We're going to do number 1 using this formula together, all right? You're welcome. Forward. 5. I think that's enough.
Did you do it?
Did everybody get one? Good? All right, let's look at number 1. We got a blank page here. So we have n equals 7. We're going to assume these are binomial probability distributions. N is 7. X is what? 1 over here. And then P is 0.01. Good. So our formula, let's look. P of x equals, what's the first term? N factorial over n minus x factorial in the denominator. Good. X factorial here. All right, we remember that from the previous slide? All right, so what in this case is n? We need to start plugging this in. And so we have 7 factorial over what? You have to be 7 minus 1. 1 factorial, which is just 1. Right. To the x is 1. Q is what? What is Q? We don't have Q. We didn't find Q at the beginning. What's Q? 0.99. Good. Yeah, 1 minus 0.01. Good. So we have 0.99 to the what? 7 minus 1. Yeah, sure. Okay, we got it. And that is 6. So here is our formula for finding our probability here. Alright, so 7 factorial over, this is going to be 7 minus 1 factorial, right? So that's going to be 7 times 6 times 5 times 4, etc. This is going to be 6 times 5 times 4 times 3, all the way down. So the 6, 5, 4, and everything is going to cancel with everything down here. We're going to be left with 7 on the top. Alright? Everybody see that? That's how this stuff works on this side. So we have a 7 here times 0.01 to the first times 0.99 to what? 6. Good. Alright, so why don't we plug that into our calculators? Let's see what we get. I think we can just go from that step right there.
I got 7.
You got 7? 7%? What was the decimal you got?
You don't need a factorial. Factorial? Yeah, when you're doing like this,
What did you say? Oh, why not? Perfect, yeah. Actually, let's do 4. That's what I have here. But
6, 5.
perfect, good job. That's the correct answer. Nice. Everybody getting that?
You don't need to give the factorial. It's 7.
We're just typing in this bottom part here.
Yeah, that's what I was trying to say.
We can leave it at the decimal. It represents the percent. We good? All right.
How did you type it in?
According to some insiders, our answer is
That's what I did. And it showed me arrows.
So it was like
I think I know what I did.
6, 5, 9.
You don't
I
need
think
the
instead of
division. You don't need the division tool.
People getting that number? Everybody see that? Alright, good. Yeah, 7.1, 0.01, and then 0.99 to the 6th. That's all we gotta put in here. Alright, let's move on, or actually move backwards really quickly. We're gonna do that same problem again, except with a little bit more calculator help. Alright, so we're gonna do this way. Alright, so this way we don't have to do all the crazy factorial stuff. Alright, we have this function in our calculator, and we can type it right in. Let's see if I can find the calculator. Alright, so for this example, we have 7, right, as n, so that's the first thing you put in. And we're going to go to math. Alright, people seeing this on your calculator? I'll let you guys catch up with me. So, first thing you put in is a 7. Alright, then we're going to come back. If you press this math button, it gets you, you should see a screen that looks like that. We're going to want to go over to the probability page. Alright, and down to this NCR. See that right there? That's our goal. So we pop that in, we put the 7 as a superscript here. C, and then what was X? X is the other part, right? We're looking for 1. 1, alright. So then we're going to move over so that we can move up. We can multiply now. Times, what is the, let's go back to this really quick. So we have this NCX part now, but now we have to multiply it times the last part, like up there. Alright, so we have P to the X and then Q to the N minus X. Again. Yes?
So both of these formulas for 1 period.
Yes. So yeah, it's the same way. This way you just don't have to do all the crazy factorial things over here. Sometimes that might be easier for you, but I figured I'd show you with the calculator. Anyway, so let's go back to the calculator again. So we have that. So in this case, we need, what was the last half of our equation last time? We got P to the X, which in this case is 0.01, yep, to the first. Then, and then it was Q to the N minus X, right? So what's that? Good. To the what? 6. Let's see if we get the same thing. We should get 0.0659. Yeah. Does that make sense? Alright, you guys understand how to find this part of the equation? Alright, we put in the first x term, or not the x term, we put in the n term. We go to math. Alright, we go over to probability. Oops, 1, 2, 5. And then we go down to here. Alright? That's how you find that on your 84. Make sense?
Yeah.
Perfect. Alright, we have a worksheet to start working on. And we're going to be going for at least the first 4 problems if we can. You can use either formula you want. Do we want to look at the binomial PDF part of the calculator?
Let's do the first 4 with
Okay.
the formula, then we can show them the binomial distribution.
Sounds good. So you can use one of these 2 formulas. I'll leave them up here for you. We'll come around and help you. There's a slightly easier way on this calculator, but it's still just calculator. You should understand which. If you have questions, let me know.
Oh, you were there. Oh, that's that bad.
If you need a calculator, feel free to grab one.
So do you have every single answer to this one? Or do you have the
You
calculator?
have to have one here, that's on What is this? Alright. Cool.
I'm not gonna grade it until like 2 weeks.
No, she's gonna grade it all. And all of them.
Excellent.
Just at least the first four, but
Does
keep
that
going.
make sense to you?
Yeah.
And we always get our failures from the probability of success.
One in the six.
Just,
The cube. Yeah. The n minus x. 7 minus 1. For the cube, 7 minus 1. And then for the one that is all the
For what?
For what did you do?
I just put 2
And then all the missing work?
Yeah.
What is that?
Yeah. When I was on my
What?
Q is always, what was
I had surgery. Like, I wasn't doing nothing.
right, you subtract, yeah, 1 minus b.
She had helped me with some of it. That's right. I thought it was I don't know. Really boosted. Like 80.
Let you know if the calculator is right.
Is that what?
Oh yeah, she said natural disaster.
So glad.
It's really easy. You can cheat it very easily. Cheat on every test.
You're taking some
Not every
tests
test,
lessons?
but a lot of tests.
Are you taking
She's over at 55, right?
Are you gonna take
Yes.
tests? I don't know, because not every still we have to present and stuff, so.
Wow.
I don't want to do
It's
that.
What is it?
Yeah, this is-
You don't have to do it.
I'll take a science instead.
I'll just have another.
Yeah, whatever.
I don't want to take that. I don't want to take math or something.
You think it's really, or just take math?
You already got accepted into college and there's always one.
Are we just doing the first four?
No, keep going. If you got the 4 done, that's great. We wanted at least that, but keep going with it.
You didn't even
So if you don't have any
I know.
problems, I think
I
what
was
we'll do is we'll post the first 4 answers so that way you know you're on the right track.
Oh, I can pull it.
It's the white circle with a pen in it.
So we all do this one. Alright. I'll put it up in a second.
I have in some of the categories.
You have 107.
What is the rounded? And then in the homework category.
How did you do the bonus problem?
Okay, so I was really hard about it. You know, yeah, that was fun.
Yeah, it's similar to the one we were doing, and then we're gonna write it out as like a chart.
Or basically, like
I don't know
4
where
out of
the
5. Like what's 4?
But you were gonna listen at the chart, and then we'll find out.
What is part of that?
So, okay. So, I had to like, what was the denominator? That was the, for 5. Sure. And then, same thing, 4 on top. And then line through the on top. And then find that answer in exponential. And then,
I don't think it was
Good. Putting up answer number
like, she
3.
was surprised. Like, she was really surprised by everybody.
I have a question. So when we do
Okay.
All she had, like, anytime I look at her, she's operates. All she very smart. She don't like doing work.
Yeah.
I usually not do everything.
Yeah.
Like, literally before every test, I'll learn how to do everything the day before.
Yes. You can probably leave it as a fraction. I mean, yeah, I think you can leave it as a fraction. You can do a calculator. It'll mean the same thing. The calculator will tell you for decimal for you. Yeah, one minus that would compute, so that'd be 2/3. I mean, or you can write it as a non-repeating decimal. Good job, good job. I'll put up number 4 now.
Only teachers that like will read a whole book to you is Mr. Nelson.
Literally, oh my God.
Mr. Nelson, bro.
All right, let's go back up here really quickly.
Do you have any other?
Did everybody get these 4 answers? Everybody get these answers up here? Good? All right. We're going to come back over here. There's one more thing on the calculator. One more thing on the calculator I want to show you. So we can come over to math and use that formula with the NCR function, right? There's another way to do this distribution, all right? So we have this var button, but we had second var that gives us distribution stuff, all right? On here is a nice big list of shortcuts in your calculator for doing problems like this, statistics stuff. So we come down a ways. It's going to be a bit of a haul. We want this binom PDF, all right? See that there? The BINOM stands for binomial, right? Like what we've been talking about. So we hit enter there. It pulls up this page. So let's do number 1 again. All right. So what's n? 7. So that's the number of trials. We put 7 there, right? We go down. What's p? P is probability of success, right? What's p? 0.01. Good. Come down, x value. That's yes. Good. And we're gonna get the same thing. All right. There you go. See, identical numbers. Does that make sense? So how do we get there? Second bar pulls up the distribution page. All right. We scroll down. So I think it's a capital A. Right there. You have A, binomial PDF. Go with that? Yes. Oh, you think it's you? Thank you.
Wait, which one?
They're not.
I only have 3 days. I turned the rest of it.
All right. Any questions on this part?
Really?
That makes sense with your calculators?
Wait, I just don't know. Were you listening when he was like showing us up on the calculator?
I'm just going to go longer.
So what are these calculators?
You guys doing the senior slide. The senior slide. I was doing that at the
So There's a couple ways to do it. I got like one was the way I used to
really think
Like when I had
what?
There are two formulas here. This one's really
Did you ever,
I need some food.
we had the same question? I don't think so. Yeah.
I can see passion.
I'll let you have it on.
good days.
Right?
I feel like
So
Oh, I remember that. 10? Wait. Yeah, isn't it the number chart?
You didn't even, oh, you
Alright, so in this case, what's Yep. So yeah, this part
I want to solid.
But I had zero
key is going to be that key is a probability that it will have a success. And then Q is the only center.
I don't know it.
So, E was a probability.
I don't even know how to knock
Q is your probability. You should have all of them.
What's this? I'm like,
You should have one.
This year, my brother
that's all I'm sure.
So what's 1 minus 0.0? But it's 0.0.
It better be showing up next week because I'm like, you'll be clean. I'm like, okay.
That'll be wicked. Alright, so now the trick
Wait,
Me and my sister heard my dad.
for probably. It was the chart yesterday, right? Or
I'm like,
okay, that's all I wanted.
she didn't like me until she had called my dad. She had a conversation with my dad, and then she started using it. She must have liked my dad. She didn't like me. She liked my dad.
kind of on
Are we gonna have a work session?
Yes, tomorrow we're gonna finish our analysis.
From yesterday?
Yep, and then we'll have a work day where you, like tomorrow and Friday, nothing new, just like catch
Any
up.
other questions, guys? Great.
Wait, Wait, so that oral thing? Oh, I get it? Wait, did you actually have to like read it? Like, edit it?
I don't know that. Should we go? Okay, then I waited 10 minutes.
I don't know.
And then I went up to 20 minutes.
It felt like 2 minutes. It was just like my third. Yes, it is my senior. Senior job. Wait, did you? I did that.
1 second.
I don't know. Really? Did my friend? That's like a good seed.
Yes. You got a question?
It's super cold. Yeah. Really? Can I see yours? Oh, that one. I like that. That looks like where was that?
I went to after in there. But I'm still here.
Like great figures. Boy, that's some, you know, like, walk like this. Like, what's this?
Okay, tomorrow we'll finish our notes and bring this worksheet so we'll have a work day on it. See you tomorrow.
Here's the next answer for you.